Hello guys, welcome back to Mason African Motives, still on A-level mathematics. In this platform, we shall be working on relations. That is the part that we have on functions. So this is an introduction that we shall have. So we shall quickly rush through the part of the class that we are having today on this platform. So what I'm going to explain in this case is the application of a functions, what we have, or how are we going to see a function, what we are going to see on the domain, also the part of domain and what and range. This is most important in our syllabus, and also the types of functions that we have. And also the inverse of a function. This is important. The inverse of a function. That's the inverse of a function. All right. Then the composite function also, if the time is going to be manageable. Okay, so we also need to see the composite functions. Okay. All right. So let's see, guys, what we have here. So first thing that we have is for a function. How are we going to see that this is a function? What is a function actually? Because we'll be talking about this, f of x is equal to this and that. All right. So let's say we are given a function in this case, and we want to actually see that this is truly a function. We can test a function by using what is called the horizontal line test. So in our syllabus, we are required to know what is referred to as the horizontal line test. So we've got the horizontal line test. Okay, so the horizontal line test, guys, as we can see, a horizontal line is a line like this. Okay, so let's say we are having a function in this case. So a function is said to be 1 on 1. Okay, if a horizontal line cuts the graph of f only once. Okay, so we can have this as a function. That is, for each value of x, there is one corresponding value of y. Okay, so what I'm trying to say is that we can have a function like this. So I just hope you were writing down what I was saying on that part. Okay, so I'm saying if we are given a function and we've got the values of x, let's say this is the graph of y is equal to e to the exponent of x. Okay, something of this nature. All right, we've got a curve of this y is equal to e to the exponent of x. Okay, if you can see that by drawing a horizontal line on this graph, okay, let's say you have drawn a horizontal line at any point that you can think of, as long it is a horizontal line, it is crossing or it cuts this graph only at a single point like that. Okay, so that shows we've got a one-to-one function since it's a horizontal line. So this is a one-to-one function. All right, we've got a one-to-one function in this case. All right, so the horizontal line is just going to cut at one point in this case. Let's say where we are referring to A or we are referring to B, whatever, but the horizontal line is just going to cut at one point. Okay, so let's say we have got, we can have a function or a graph which is not a one-to-one, but it can be a one-to-many. That is, for the value of x that you have, it will give you two corresponding values of y. Okay, not actually like that, but something of this nature. Okay, let me show by drawing a graph. If I am drawing this, it can be easier for me to explain what I want to explain here. Okay, I want to give an example of a quadratic function. Okay, we have talked about this. Okay, let's say I've got a quadratic function of y is equal to x squared. Remember this graph, it passes at 0 and it goes back like that. Okay, so if you are given this graph of y is equal to x squared, if we have got the value of x here, which is 1, we are going to have a corresponding value of y. The value of x, which is 2, we are going to have the corresponding value of y. The value of x, which is -1, you have the corresponding value, and so on. So each and every value of x that we have, it is giving us a certain corresponding value of y, which is a single value of y. Okay, so but if we are to draw a horizontal line, it is not going to be like this from the previous case. Let's say we have drawn a line like this, it's a horizontal line. We can see that it is crossing, or it cuts the graph at 2 points. We have got this point, let's say this is our A, and this point, let's say this is our B. Okay, so it's no longer a one-to-one, but this is it's no longer like we're having one-to-one a function where we are simply crossing a horizontal line at 1 point. This one, it cuts at 2 points. Okay, but still we are having this as a function from the horizontal line test. This can be the best way to explain. But as for the values of x that we have, we can see that each value of x that we have, it corresponds to one value. Each value of x, it corresponds to one value of what? Of a y. So numerically, we can say the relationship where every input has exactly one output for one function. That is what we have. Okay, so this, we can say a function is a rule which maps a single number to another single number. Like what we can see, -1 corresponds with the value of y, 1 corresponds, so it corresponds to a certain number. Okay, unlike we cannot, if we can put those trigonometric functions where we can have maybe 2 possible values, or let's say we've got this type of a graph. Y is equal to the square root of x. Okay, the square root of x. You are going to see that for each and every value of x, it will give you 2 possible values of y. It is going to be y is equal to plus or minus. Let's say x is equal to 4. The value of y is going to be plus or minus 2. Let's say x is equal to 9. Y is going to be plus or minus 3. Okay, so we are going to find something of this nature. Your graph is going to be like this. I want you to see how it is going to look like. Okay, if we are to sketch this graph like this, we are going to have something of this nature. Remember, it's a plus or minus. So each value of x has got a plus and has got a minus like this. Okay, so this one, if we are to apply the horizontal line test, are we going to win this case? Okay, are we going to win? We are going to see if we draw a horizontal line, the part of the other curve is remaining in this case. So this one is going to work with a vertical line test. Okay, so this one, you use a vertical line test. So from the vertical line, we are going to use it at this point. Okay, so this is how the vertical line test is going to look like. Okay, but it's not actually necessarily, oh, you're going to find questions like this. Just you need to know your typical questions. So this is y is equal to square root of x. Okay. So let's check the other part again. We can be given to draw a function given a certain values of x. Okay, so that's where we have got the combination of these words, the range and the domain. Okay, so I'm going to start with the range. Okay, so if we are given a range, we are saying that these are the values of y that we have for a function. Remember, a function is given as y is equal to f of x. So the values of y for the given function, that's the range. Like, for example, we sketched a graph. Let me explain with a sketch so that you can understand what I'm trying to say here. Okay, this graph is ugly, guys. Let's try to redo. Okay, something like this. All right. So let's say we have got our graph here, guys. That's okay. I'm going to take this as a quadratic graph. Okay, I'm just going to take a quadratic graph in this case. Okay, so let's say we've got a quadratic graph like this. All right. Then at this point, our graph is located at a point where it's exactly the maximum point. At that point, maybe it's a 4. Okay. So the values of y that we are referring to are the values that the graph is operating from. This graph cannot exceed 4. It is limited at 4. But as it goes down here, remember this part here below the x-axis, we are going to have the values of y up to infinity, up to the negative infinity. That means we are going to have endless values of y. Okay, so which means the values of y, which represents f, can be taken to the values which are greater than or equal to the negative of the infinity up to, okay, so this is infinity, guys, like this, okay, up to the positive 4, limited at 4. They are going to be less than or equal to 4. But if you are given a certain consideration where the graph is drawn, given the domain, okay, so now we have got okay, let's just not talk about the domain for now. We're gonna confuse each other here. Let's say we have drawn our graph, guys, and we are limited, and we actually know the value of y at this point, and we know the value of y that where our graph is limited according to the values of x that you are given. Let's say you are given your values of x from -1 up to x, which is maybe a 7. Then from those values that you have drawn, you know that your graph maybe is at 4, and here it's limited, maybe it's at -6, like that. All right. You are no longer writing it as from negative infinity up to 4, but you are now limited from -6 up to positive 4. So you can write that the values of y represented by f are greater than or equal to -6, but less than or equal to 4. You are now writing as per the given graph that you have. That is how you take the range. Okay, so range affects the values of y. This one, it affects the values of y. That's the values of y. And domain affects the values of x, where we are operating from, where our graph can be operated from. That's now the domain. Okay, so what I'm simply trying to say, guys, is that if we are given a graph in this case, let's say we've got f of x, which is equal to x squared, okay? Then from our f of x, which is equal to x squared, we are given that our x is greater than or equal to -1, less than or equal to 2, okay? We are asked to sketch this graph, okay? So what we need is to sketch the graph. And after sketching, we need to state the domain or the range. Sorry for that, guys. Sorry for that. And state the range, okay? State the range, okay, of the function of f of x, which is the range of f, okay? So from -1 up to +2, you are limited for the values of x that they are not supposed to be out of this region, okay? So that means if we are to see here, guys, it's just like we are having, I'm just gonna show you a table here. We can just have a small table to represent the values of x versus the values of y. Okay, so let's say we've got x here, and this is y, where we've got -1, -1, 0, 1, and 2. Okay, so let's say this is what you have on your table in this case. Okay, so from the graph or from the table that we have, the corresponding values of y is going to be at -1, we square, that's -1 squared, which is 1, 0 squared here, that's 0, 1 squared, which is 1, 2 squared, which is a 4. So as we know from our graphs, guys, in our O-level mathematics, we used to draw this graph, but here we are not going to draw, we're just going to have a sketch. In fact, this table of values is not even necessary, but just for us all to understand what is happening here. That's why I'm showing you these values of x. So you're supposed to have your graph in this case, all right? This is how your function was supposed to look like, all right? Sorry there. I've used the part that I didn't want to use here. I need this one. Okay, so this is your x, and that's your y at this point. So we've got it is 0 here. Okay, so let's say this is -1, this is 1, and this is 2. All right, so we've got 1, 2, 3, and 4. We do not have negative values, but let's just see. All right, so the first point is at -1, 1, which is -1, 1 at this point. Then is 0, 0 at this point. 1 versus 1 at this point. 2 versus 4 at this point. Okay, so the graph that we're supposed to have at the end was supposed to be like this, from this point up to this point here. All right, so we are limited where x starts at -1, and at that point y is equal to 1. And we end where x is equal to 2, and at that point y is equal to 4. So now if we are given now to determine the range of this function, it means the values of y will be limited at where we can see, okay, what is the maximum now? We are now talking about the maximum and the minimum values of the function. So we are going to see that at this point, our y is at 1. It goes down where at this point, y is equal to 0. So that's the minimum value that we can have. It goes up, this function goes up up to this point, which is the maximum value where y is equivalent to 4. So you can say that y is greater than or equal to 0, but the same y that we are talking about cannot exceed 4. So that means it's less than or equal to 4. So that's what you're actually representing in this case, and you are referring to the values of y, or the real numbers that we can talk about. Okay, so I think basically we just have this information of what is actually a function, or how do you sketch a function, a quadratic function, this and that. What is function actually? Okay, so the other part that you're going to have is to find the inverse of a function. Okay. So we have got the inverse of a function. So that's the inverse of a function. So also on the inverse of a function, I'm going to explain the domain also, which is very, very important. Okay, so if you are given to determine the inverse of it, it depends with the type of a function that you are given. Okay, so in this case, we are going to start with algebraic functions. Okay, so let's start with algebraic functions. Algebraic functions, just a normal algebraic function that you can think of. So that's what you're going to have in this case. Okay, so if you are given to find the inverse of function, I'm going to illustrate with an example. Okay, so the question is, in this case, let's illustrate with the question, then I will explain from there. Okay, so the question can be, find the inverse, that is, find the inverse of a f of x, which is given like this, okay? Then stating, take note about this, stating the domain, okay? So the domain, that is the limiting value of x, where our graph is limited, okay? So we are saying, where our, okay, let me explain this way. You can understand from this one. If you are given, let's say for an example, f of x is equal to 4 over x. I want to write it like this, 4 over x, like this. Okay, it's a function that we're given, an inverse function. Okay, we know that we can never have a condition where in the denominator x can be equal to 0. If you are to use your calculator and simplify y is equal to 4 over 0 like this, you are going to obtain maths error. That means this does not exist in maths. We cannot have our denominator being equal to 0. So that's where we are limited in terms of x. We are limited in a way that our x can never be equal to x. But this x being an element or being part of all the real numbers that we can think of, but x can never be equal to 0 as long as it's in the denominator. That's what we refer to as the range. Let's take for an example of a square root. You are given, for example, f of x is equal to the square root of x. What you are simply asking yourself is that, what limits the square root? What are the limitations of a square root? Can we find the square root of a negative number? That is what you're asking yourself. We can find the square root of 0. We know that the square root of 0 is a 0. We can find the square root of 1. We know that the square root of 1 is plus or minus 1. We can find the square root of 2 using our calculator. We can find the square root of 5 using our calculator, but as long as it's a negative, we can't determine the square root of a negative. So what does it mean? It means for whatever value of x that we can think of, this value of x must be greater than 0. Or we are simply saying our values of x can never be less than 0. X can never be less than a 0, which means it can never be less than 0, which means we are referring to any number less than 0. -1, x cannot be that number. Or we are simply x is greater than 0. So a domain is the way we are limited in terms of a function. Okay, so I think as we are going to be having examples and so forth, you are going to understand me, guys. Okay, so anyways, this is what we're going to have for the inverse of a function. To find the inverse of a function, let's say we are given a question like this. We are asked to find the inverse of a function, and the function that we are given in this case is f of x, which is equivalent to 3x over x plus 5. All right, that is what we are given, and we are given our x limited that x can never be equal to -5. Okay, like I was saying in this part, remember, this is the domain that you are given. Remember what I told you, if you are given a fraction, x can never, the denominator can never be equal to 0. So what you simply do in this case, how do they know about this, that x can never be equal to -5? Since we said the denominator can never be equal to 0, you simply solve x plus 5 is equal to 0. So x is equal to -5. It means when x is equal to -5, your denominator is now at 0. And the denominator cannot be equal to 0. So that means x must not be equal to -5, or x is not equal to -5, because when it is at -5, our denominator is a 0. And that means it's no longer a function. So we are limited that x cannot be equal to -5, but x can be any number that you can think of. All right, so that's what you refer to as the domain. I hope you understand. I hope you understand. If not, you are going to understand me as we are going to be revising the equations. Okay, so we are here, guys. Remember, the question is to find the inverse. Okay, so this is what you're going to do for each and every condition to find the inverse. These are the steps that I want you to take. Okay, so what you're going to do is to equate, all right, equate the given equation to y. Equate the given equation to y. Equate the given function, sorry, that's a function, this one. So you're going to equate the given function to y. So you're going to be like y is equal to, you're just introducing a certain equation of your choice. Okay, then from there, what you do is that you make x the subject of the formula, okay? Make x the subject of the formula. Make x the subject of the formula. So we are now back to our O-level mathematics there. So whereby we're going to make x the subject of the formula, okay? After making x the subject, replace, all right? So this is it, okay? So we are going to replace y by x, okay? Replace y by x. Okay, so the moment you replace this y by x, that's your final answer. That's the inverse. So by replacing y by replacing y, okay, sorry, let me write properly. By replacing y by x, that's the final answer. That's the final answer, which is the inverse, which is the inverse of the function, okay? So that's the inverse of the function of x. So guys, do not mind my grammar, okay? So you know how to have this properly, but just for me, just if I just write in a way that you understand, okay? So that's our f of x here, which is equal to 3x over x plus 5. So the first thing we are given, we are going to equate this to, say, a function of y. So it's going to be y is equal to, so let me write it down here. So instead, we are going to have as y is equal to the whole of the function that we are given, which is 3x over x plus 5. So this is going to be 3x over x plus 5, all right? So we've got 3x over x plus 5. After writing this, make x the subject of the formula, okay? So we're going to make x the subject, okay? That's make x here, make x the subject of the formula, okay? So making x the subject of the formula, what can we do, guys? From our O-level math, we can cross multiply here. So the moment you cross multiply, that's y is going to multiply everything here. Y times x, that's yx or xy. So you can write as xy. Then y times 5, that's 5y. Okay, we are going to have 5y is equal to 1 times 3x, which is equal to 3x. So remember, we want to make x the subject. So we are going to collect the terms with x to one side of the equation, then y to one side of the equation. And by doing so, just avoid to work with negative values, guys. Just avoid that. Okay, so I can leave the 5y to this side. That's 5y is equal to 3x. Transpose xy to this side is going to be minus xy. Okay, if you wanted, you could have left this xy. That would be xy, then transpose 3x, it will be minus 3x is equal to 5y to this side, it will be minus 5y. But just avoid working with negatives, guys, of which you can calculate that way. It's still one and the same thing. All right. So x is common, so you can factor out x. That will be 3x divided by x, which is 3 minus y. Okay, so guys, we know that from our O-level maths, we are going to divide by the bracket. Okay, sorry, guys, by the way, that I'm keeping on repeating O-level maths, but I hope we understand we did this before. Okay, so therefore, okay, before that, we are just going to write as x before we conclude. Okay, so let's write our x is equivalent to 5y over 3 minus y, like this. Okay, so we have our x as the subject. What you're going to do is that in place of x, you're going to substitute y. In place of y, you're going to substitute x. And that is going to be your final answer. So if we are going to do this, that means here, in place of x, that's y is equal to. In place of y, you substitute with x. So this is going to be 5x over 3 minus x, like this. Okay, so this means that's our inverse of what? Of the function with respect to x, which is equal to 5x over 3 minus x. Okay, so that is your inverse in this case. All right, so we remember we need now to know what are the limiting values of x, which is the domain now. So how is our x limited? Remember, it's a fraction. So it means in this case, our denominator cannot be equal to 0. Okay, so that means we are just going to find the value of x, which makes this denominator to be equal to 0. So we equate our denominator to 0. So x is going to be equal to 3. So if x is equal to 3 in this case, it means that our denominator becomes a 0. So to avoid that, that means our x cannot be equal to 0, because if x is equal to 0, our denominator is going to be a 0. So if x is equal to 3, our denominator is going to be 0. So therefore, our x is not supposed to be equal to 3, because when it is equal to 3, our denominator is equal to 0, and that means the function is not valid. Remember, I told you guys, you cannot have a condition of 3 over 0 or 10 over 0, this or 10 over 0 like this. This does not exist in mathematics. Okay, so that's invalid. Okay, so that's how you simply determine the inverse. So it can be a fraction, it can be any typical question, but mostly they will give you fractions like this. So I hope you understand how you're going to find the inverse if you're given such type of a question. All right, still on functions, which is algebraic functions, we can have this as a quadratic function. So let's just separate this and have it as a quadratic function. All right, quadratic function. We know that our quadratic function is f of x is equivalent to ax squared plus bx plus c. Okay, but now take note of a quadratic function. You are given a function, let's say, for example, that's f of x, which is equivalent to x squared minus 5x plus 6, like this. Okay, and we are given that in this case, our x is greater than or equal to 3. Now you're asked to find the inverse and the what in the domain. Okay, So how are we going to find the inverse of this quadratic function? All right. As you can see, remember what we said, guys. We have to make this in the form of y is equal to, that is y is equal to x squared minus 5x plus 6, just like what we did there. Then you are supposed to make x the subject here. Make x the subject. But how can we make x the subject of this formula, guys, if we are given x squared and x? It's impossible for us to do this like this. So what you're going to do is you're going to work out by completing the square. In your O-level maths, you used to say, this is impossible. You can't make x the subject. It's very, very possible by completing the square. So as long you are given a quadratic function, you are going to complete the square first. Complete the square. So the moment you complete the square, then you can make x the subject just like any other equation or any other function that you can work with. Okay, so we are going to complete the square. That is x squared minus 5x plus 6. Completing the square, remember guys, I talked about completing the square in a separate video. I hope you understand. If not, make sure that you watch completing the square method for mathematics N3. Yes, for mathematics N3, if you search mathematics N3 completing the square at Mason African motifs, you're going to see another part that we did on completing the square, or just search completing the square method, okay? Completing the square at Mason African motifs. That part you can see questions on completing the square that I have done before. Okay, so this is what you're going to simply do. Remember, to complete a square, you need half the coefficient of x. Already the coefficient of x squared here is a positive 1. So what you're going to focus with is half the coefficient of x. Then you square that half. So it's half of negative 5, then squared. Okay, so half of negative 5 is negative 5 over 2 squared. Okay, so this is the part that we are going to add into the expression that we are given. So this is going to be x squared minus 5x. Remember, you add after where you have find the half here, you add the square. So this is our square, which is negative 5 over 2 squared, okay? Plus 6, the one that we are given already. But take note, we have changed our question, so we subtract that square again, which is minus 5 over 2 squared. So here I'm just explaining, I'm just working, but I hope you know the basics here. Okay, so to complete the square, we are going to focus with the first term and the last term. So this is where you complete the square from x squared up to negative 5 over 2 at this point. So you work with the first term, which is x squared, and the last term, which is minus 5 over 2. So we are going to obtain x minus 5 over 2 squared, which is, you combine this plus the part 6 minus 5 over 2 squared. Okay, so let me just show the whole screen so that we can see our calculator here. Okay, so this is on the calculator. So you've got 6 minus, you open bracket, that's minus 5 over 2. So you put minus 5 over 2 squared like this. All right, so this is what you're going to have. So if you simplify, you are going to obtain negative 1 over 4. So that's negative 1 over 4 in this case. All right, so you've got negative 1 over 4. So this is the part that you're going to obtain after completing the square. We are going to obtain the whole of this function that you're given here. All right, so this is the one that you're going to take, because we can make x to be the subject here, because you can see that x is no longer, it's just a single x here. So we can substitute now into x squared minus 5x plus 6, the whole of this expression, because it's the same answer. So we're going to have x minus 5 over 2 squared minus 1 over 4. All right, so let's try and make x to be the subject. This is the question now. How can you make x to be the subject at this stage? We can transpose negative 1 over 4 to the right-hand side, to the left-hand side. That is going to be y plus 1 over 4, since it was a negative here, is equal to x minus 5 over 2 squared. Remember, to make x the subject, it's like you are solving for x. You are actually solving for x in this case, all right? But you are solving in terms of y. So to remove the squared, which is affecting here, remember that you're supposed to introduce the square root both sides. So it's the square root here. the square root here. So that is going to be, remember the square root of n number is plus or minus. So we are going to have it as x minus 5 over 2 is equal to the square root of y plus a quarter, which is plus or minus the square root of y plus 1 over 4, everything under the square root. So to make x the subject, I can simply transpose the minus 5 over 2 to the other side of the equation. So x is going to be positive 5 over 2 plus or minus the square root of, so you can write this as the square root of y plus 1 over 4. Okay, so it depends with your presentation. Some might choose to combine this to be a single fraction, but some might choose to just leave it like that. Okay, so as for me, I'm just going to leave it at this stage. So after making x the subject, remember the requirement now is to replace. In place of x, you substitute y. In place of y, you substitute x. So it's going to be 5 over 2 plus or minus the square root of x plus 1 over 4. So this is your inverse. So therefore, the inverse of f of x is equivalent to 5 over 2 plus or minus the square root of x plus 1 over 4. So that's how you simply work out a quadratic expression. But what about the domain now? What are the limiting values of x? Remember, I told you guys, whenever you are given a square root, you simply work with the square root to say that you know that we can't determine the square root of a negative number. All right. So the most significant value that you're going to work with, it's a 0. So if you are to equate x plus 1 over 4 to 0 here, we can see that x is equal to minus 1 over 4. At x, when it is at minus 1 over 4, it means you are now at 0 when x is minus 1 over 4. But we are limited that our square root cannot be less than 0. All right. The value of x cannot be less than 0, which means our value of x that we are supposed to talk about is supposed to be greater than or equal to a 0. It cannot be less than 0. So it must be greater than or equal to 0. Okay. Or you can write in any other way that you can think of. Okay. So if it is that way, it means when you substitute your x at minus 1 over 4, that's where you obtain a 0. So we can conclude that our x in this case, for it to be greater than or equal to 0 inside this whole of the function here, it means this x is supposed to be greater than or equal to minus 1 over 4. Because when x is minus 1 over 4, it gives it a 0. Once it's greater than it's greater than, then it gives you a value that is positive. So here not actually x, but the square root here. The square root is supposed to be greater than 0. The number that is under the square root is supposed to be greater than 0. That's what I'm trying to say in this case. Okay, this number under the square root, which is this whole of this part here. Or what you can do, you can simply work it this way, guys. The easiest way that you can simply find your domain is this way. Okay. Since you know that the number under the square root here is supposed to be, this whole function under the square root is supposed to be greater than or equal to 0. The value of x, let's say it's x. So you're simply going to take it as a function to say x plus 1 over 4 should be greater than or equal to 0. So that means x is greater than or equal to, transpose this to this side, you're going to obtain negative 1 over 4. So it means that's our domain, where x is every element that you have for all the real numbers that we have. So this becomes the domain, and that's your inverse. So as long as you are given a quadratic function, try by all means to complete that that quadratic expression by completing the square method. After completing the square method, you can now make x the subject. It's now possible because it's simply following the stages that you know, guys, removing the square, transposing of functions, and you can see that your x is the subject. So it's simply like that. Okay, so I'm not going to waste much time for this one. We are going to work on another one so that when you are now working with question papers, we can do more questions. For now, I just want you to have a hint or just what is happening when you are dealing with functions. Okay, the other part that you can have, I don't know, it's number what now, maybe it's number 3 or number 4, but now it's on exponential functions. We want to know how to determine the inverse of an exponential function, inverse of an exponential function. That's an exponential function. All right. An exponential function, I'm referring to something of this nature. Y is equivalent to e to the exponent of f of x. That's an exponential function. Okay. So the stages are the same as what we saw previously. We have to make x the subject, what, and so forth, whatever that we have. Okay. So what you want for an exponential function, this is what is going to happen here if you're dealing with an exponential function. Let's say we are given the function of f of x, all right, where we've got our f of x being equal to 2e to the exponent of x minus 3. Okay, so take note, this is an exponential function. An exponent is not limited. Remember, we say domain is the limiting value of x. We cannot limit an exponent, e to the exponent of e to the exponent of e to the exponent of a positive, whatever number that you can think of. So that means for e, we are not limited to say x, it can be equal to 2 or x cannot be equal to this number. So x is going to be the element of, is going to be a subset of all the real numbers that you can think of. It's not limit, x is not limited for an exponential function. Okay. We are worried about how to find the inverse. Okay, these are the stages that you're going to take. Okay, remember we are told that we have to make this as y is equal to, okay, so you're going to have as y is equal to 2e to the exponent of x minus 3. Okay, so what you need whenever you are dealing with an exponential function, you are going to introduce a ln. But before introducing a ln, make sure that we have got a single exponential, which is a single e to the exponent of f of x. It must be a single term. When I'm referring to a single term, there must be no single number like like 2, like any number you are adding. You have to remove all these numbers. You just remain with e. All right. So this is what you're going to do because this 2 is affecting. So you can divide by 2 both sides. All right. So that we can just remain with e. So if we divide by 2, we are going to have it as e to the exponent of x minus 3 is equal to y over 2. Remember, the main purpose is to find x. Okay. So if you are given e, you are going to introduce ln because we can't make x the subject. It's on the exponent. So this is what you do from your logarithms. You introduce ln both sides. Okay. Not log, but ln, a special type of a log, which is the Napierian logarithm. Okay, so this is the one that you're going to introduce both sides. Okay, so what am I trying to say here is let's introduce and see what you're going to have. We are going to have this as ln both sides. So it is going to be ln e to the exponent of x minus 3 is equal to ln of y over 2 like this. Knowing that from our laws of logarithms, we know that the p logarithm of x is equivalent to, okay, given like this, p log m is equal to log m to the exponent of p, which is ln is same as log. So we are given an exponent of x minus 3. So we are supposed to multiply the log by the number of x minus 3. So this is going to be x minus 3 ln e. Okay, that's ln e, which is equal to ln y over 2. Knowing that ln e is equivalent to 1, okay, from your logarithms, I talked about this, that ln e is equal to 1. So if ln e is equal to 1, that means this whole part can be written like this. This is going to be 1. So which means we are just left with x minus 3 is equivalent to ln of y over 2. All right. So how can you make x the subject? Just transpose -3 to the other side is going to be a positive because you are subtracting, you add both sides. So 3 plus the ln of y over 2. That is now so x. So therefore, our inverse, remember, the inverse is simply taken from the x that you now have. That's where you now have your inverse. So therefore, our inverse of x is going to be, all right, before that, okay, before that, we didn't we didn't transpose here x and y. So you just have to interchange first, okay? Remember that you transpose, so y is equal to 3, the ln of, okay, so this is 3 plus the ln of, in place of y is going to be x. So that's x over 2. So don't forget like what I almost did here. So this is 3 plus the ln of x over 2 now as your inverse. Okay, so the domain, what is going to be the limiting value? We are now referring to ln. There's a ln in this function. Ln is a log. Ln is same as a log, okay? And we know that for a log, we cannot have a value like log 0, log -1, log -2. That cannot never happen. So it means our x is limited to a values whereby the whole of this function, if it is ln f of x like this, the whole of the function of f of x must be greater than 0. We can never have our function of ln being equal to 0 or less than 0 because that's impossible. Just use your calculator, log 0 or ln 0, you'll see that you're not going to obtain an answer from there. So that means for what is going to be the value of x if this is equal to 0? So you simply equate this to 0. X over 2 is equal to 0. So x cross multiply, x is equal to 0. All right. So that means we can conclude that when x is equal to 0, all right, when x is equal to 0, it means this part with the ln is equal to 0. So, and as we are saying, this function can never be equal to 0. So that means our x is greater than 0, okay? And x being an element of real numbers. Or just take, since we said f of x is greater than 0, just take your f of x. Your f of x is what? It's x over 2. So x over 2 is greater than 0, just like that. So cross multiply, x is greater than a 0. That's your domain. So that's how you simply find the domain. You need to know the domain of a log, the domain of an exponential function, the domain when you are given a fraction, a normal fraction, the domain when you are given an exponential function, the domain when you are given a square root of a function. I explained all that. Okay, so that's how you simplify the inverse of an exponential function. So as you can see, the inverse of an exponential function is a log function, okay? It was an exponential function before, but now it's a log function. That means it's the same thing if you are working with a log function. The inverse of a log function is going to be an exponential function. So let's see as a separate part, the inverse of a log function, okay? All right, sorry for that. So we are going to have the inverse. I don't know now, it's number 4. All right, so it's going to be the inverse of a log function, of a logarithmic function or a log function. That's a logarithmic function. All right, so if we are given a log function, it's just same as the one for exponential function. So you might be given an example for, let's say, our f of x is equivalent to 5 ln x minus 2. All right. So if you are given a log function, the first thing is to make sure that you remain with a single log, just like what we saw when we were dealing with an exponential function. You must have a single log. So every number, just like 5, whatever number that can be added or multiplied or divided must be removed first so that you remain with an exponential function. So this is what is going to happen here. We are going to have y is equal to 5 ln x of minus 2. So remember, we need to have ln only. So you have to divide by 5 both sides, by 5 both sides. So y over 5 is equivalent to ln x minus 2, okay? So let me just start by writing x. It can help us so that we don't confuse each other here. So I'm just going to start this part with x, which is ln. So ln x minus 2 is equal to y over 5. This is the stage that we are. But we can see that we are limited now to remove this x because there is a ln that is there. So how do you remove ln? It's simply the inverse of what happened. You introduce the exponential both sides. Remember, when we were given exponential, you introduced ln both sides. So this is going to be e to the exponent of. So you introduce e both sides, okay? So this is going to be e to the exponent of ln x minus 2, which is equal to e to the exponent of y over 5. That's how you introduce the exponents. But we know that the e to the exponent of a log like this of x is equal to x. So that means if we are given e to the exponent of, all right, let's indicate here, right? E to the exponent of ln x minus 2, we are going to remain with x minus 2. So x minus 2 is equal to e to the exponent of y over 5. So remember, the purpose is to make x the subject. So what is limiting now? There is a minus 2, which is affecting this part. So how are you going to do? You just have to transpose, okay? Transpose minus 2 to the other side of the equation. It was minus 2, so it's going to be plus. So it's 2 plus e to the exponent of y over 5. And by that, we can say in place of x, we are going to substitute with y. In place of y, we are going to substitute with x. And this becomes the inverse. So it's going to be 2 plus e to the exponent. In place of y, it's going to be x over 5. So that's our inverse. So therefore, our inverse with respect to x in this case is 2 plus e to the exponent of x over 5. So as you can see, like I was saying, the inverse of a log must be an exponential function, because we saw that when we determined the inverse of an exponential function, it gave us a log. So it's a vice versa. All right. So that is what you're going to have. And what is the domain? Remember, guys, I talked about this when we were dealing with an exponential function. We can see that our inverse is an exponential function. And I told you that for any exponential function, it's not limited. We can't be limited to x of any value. The exponent cannot be limited. So our x is going to be just an element of all the real numbers that you can think of, as long as it's part of a number. It's not limited on the exponent, okay? So that's what is going to be our domain. Okay, so the last part is on the composition of functions. So more examples. If you've got questions, don't hesitate. Let's share on the comment section, or to just comment with your question at +27 61 864 4044. That's 864 4043. Okay, I just hope that's exactly the number there. Or just email at Admire Makufa Major, or is it Makufa Admire Major? Okay, you check on the description of the channel, the email, and also the contacts, so that we can also contact if there is anything that is of need to be done. All right, so the last part, I'm just going to introduce this part so that we finish. Instead of separating this, I'm just going to combine this. All right, we have got the composition of functions. All right, composition of functions. All right, composition of functions, guys, it's a combination. You are combining functions together. Like, let's take, for example, that we've got two functions, okay? We have got the function of f of x. So I'm just going to illustrate, which is f of x, let's say it's equivalent to x squared. And also you are given gx, which is equivalent to 3x plus 1, like this, okay? So to combine, composite is just combining functions. So I'll explain this one later on as we'll be working with more question papers, okay? But in this case, I just want you to have an idea of what is happening. You might be asked to find, okay, let's say f of gx, like this, okay? So the moment, even the way that I'm referring, it's f of gx. You can even tell what is happening. So f of gx, it means in your f of x, you are now going to substitute, in place of x, you're going to substitute with gx, okay? Previously, this was your f of x. So that means our f of gx is now equal to, in place of this x, you substitute with the gx, and our gx is 3x plus 1. So it is going to be 3x plus 1. But take note, it's x squared. So it will be gx 3x plus 1 squared. Okay, that is how you simplify this. Okay, let's say if it was like this, g f of x. Okay, so let's say it was g f of x. So it simply means in place of g, in our g, we are going to substitute with f of x. Okay, so this was our gx. So it means our g f of x is going to be equal to, this is our gx, but we substitute in place of x with f of x, and our f of x is equal to x squared. So it is going to be 3. In place of x, we substitute with f of x, which is x squared, okay, plus 1. So this is just going to be, there was going to be bracket, but as you can see, there is no need for us to have a bracket there. So that's how you combine functions, okay? So sometimes you can be combining an original function and an inverse function. There are so many ways or so many things that you can that you need to know about. Okay, anyways, that's what we had, guys. We are going to proceed, like I said, working with more questions and revisions, but in another classes that we shall have. So please invite as many students, your colleagues, your friends from your school. Please invite them, guys, so that they can learn with us. They can benefit from this information that we have as a family of Mason African motives. So that's it, guys. Till we meet again.